In this snippet, we will introduce Professor Goodenough. This is done in chapter 5 of this book. Professor Goodenough has contributed to important advances in batteries and many other fields. He has a very interesting background. So he started with BS in math from Yale University. Then he did his PhD in physics just after World War II from University of Chicago. In between, he had also contributed to some efforts related to World War II. After completing his PhD, he worked for quite some time at the MIT Lincoln Laboratory, working towards solid state memories, which are quite important for computers. The work led to what is called Goodenough Kanamari rules, amongst other things. So this is to explain the different spin states of in solids. For example, whether it's ferromagnetic or antiferromagnetic, and so on. So later, after this work, he moved on to University of Oxford in Europe, uh, where he was pointed mainly to work on solid state chemistry. So why I have emphasized these things in red is because much of the research is interdisciplinary. In cutting edge research is interdisciplinary. We can't be too fragmented and be in our own silos saying this is chemistry, physics, and math. Okay, so if you really want to do cutting edge research, you have to be capable of handling concepts from many different fields. And eventually, all this background helped him towards uh, do work on batteries, which is probably engineering, either materials engineering or material science or chemical engineering. So, which led to a Nobel Prize. Okay, so it's important to be able to work at least on two domains to contribute to some really significant research. So that is important. Um, when he moved to University of Oxford, this was around 70s. So because of certain political issues, energy crisis was the most important problem for which you needed solutions. So he worked on energy conversion, what is in electrochemical community is referred to photoelectrochemical uh, hydrogen generation. The input is solar energy, and you want to get hydrogen, which is a useful fuel as well as a fuel as well as a useful chemical. Okay, so that was one of the topics he worked on, and more importantly, in this context, he began his work on lithium-ion battery in University of Oxford in the solid-state chemistry group. Is important breakthrough that led to the Nobel Prize was in the development of lithium cobalt oxide. Okay, so that is so the Nobel Prize was given to three of the contributors for their work on the development of lithium-ion battery. So what is important to understand is much of the work is in development of new materials. Okay, so all these technology like battery, okay, solar cells, these are technologies what I call material centric devices. Even a catalyst is a material centric device. So if you have a new material that is economically viable, sustainable, and so on, so you have an important new technology. Okay, so without the development of new device materials, all these technologies cannot thrive. So the three people who got the Nobel Prize for this effort was Stanley Whittingham. He did this. He was a solid state chemist who is did the work related to Nobel Prize first in ExxonMobil industrial R&D lab. Okay, so ExxonMobil is a lab that focuses on hydrocarbon or petrol related work. So he did this work in ExxonMobil. Goodenough um, did the work that led to Nobel Prize in University of Oxford. Akira Oshino was also associated with the Goodenough lab, but also from a Japanese industry, you would see. Okay, so as we progress along this book, you would see how all these things are brought together. In the next snippet, we will introduce another scientist who has made important contribution to uh, advanced electrodes that are used in lithium-ion battery. This is the title of the next snippet. Thank you.